Hello viewers, welcome to Quick Coder. My name is Tulsi. Today's topic is introduction to linked list and how to insert elements into the linked list and how to print the elements from the linked list. Okay, so these all parts will be done in Java language. So once you learn the concept, then you can implement them in any language. Okay, so let's get started. Okay, today's topic is linked list. So in the beginning of this video, so when I told that this video is about introduction to linked list, you may get some doubt. Already we have some arrays. So why the linked list comes into picture? So arrays is also collection of objects and linked list is also collection of objects. So what is the main difference between them? Okay, so all data structures evolved because of some disadvantages of some other data structures. For example, if for arrays we have some disadvantages. The first disadvantage is we must know limit in advance. Okay, so for declaration of array, int array is equal to new array of. For example, we have to enter size in advance. Means up to that size only we can create. For suppose I created an array of size 5. Let's say this. Okay, then I inserted only 2 and 3. I used this only 2 into 4, 8 bytes of memory. Okay, and 3 into 4, 12 bytes I did not used. Okay, I did not use that. So what will happen? So this memory will be like this only, it will not be deallocated. Or for suppose I have an array of size 3 and I use this all like 1, 3, 5 and I want to insert some more elements, but I only created the array of size 3. I cannot extend the size of the array. So the memory cannot be allocated for us. And here the memory can be deallocated and it can be allocated to some other array or some other variables, but it will not be deallocated. So no dynamic allocation or deallocation. And see, irrespective of usage, I used only 8 bytes, but remaining 12 bytes are there. So memory is allocated for them also. So these are useless. So this can be deallocated from this and this can be used for other variables, but it will not be there. So these are some of the disadvantages for arrays. But these are the advantages of linked lists. Okay, we cannot I mean there is nothing that we must provide limit in advance. Okay, so what node is created? So don't worry what is node, that all the things I will explain. So in linked list we have some collection of nodes. So in this nodes we will have some number, some data in this part. This part is data and this part is for the next or address of the next node. Okay, so address of the next node. For example, this address is 102. Then 102 will be stored. Okay, so like that, this linked list will be there. So if we delete this node, so this can be, I mean, we can create a many number of nodes. Okay, or we can delete this node. Okay, that we can see, but this is something about linked list. Okay, why linked list comes into picture. Okay, so let me explain the main thing of linked lists and arrays using some memory diagrams. Okay, let me take some time for it to draw. So let's continue. So these are the bytes here. Okay, and we have some program written like this. Okay, int x is equal to 10. Then what will happen now? Okay, int x is equal to 10. Integer occupies 4 bytes. No, okay, so each block is equal to 4 bytes. Okay, so this 10 will occupy, for suppose here, let's say. Okay, it occupies this place and 10 is stored here. Okay, then again programmer wrote this line like integer array is equal to new array of 2. This integer will occupies the sequential bytes only. Means it occupies these two or these two or these two or these two sequentially. So for example, it occupies, let's say, this two. Okay. If I write something like this, if array of 0 is equal to 1 and array of 1 is equal to 2, then 1 and 2 will be occupied here. The programmer, what programmer think is, okay, I don't want array of size 2, I want some array of size 3. And I want to insert like array of 2 is equal to 3. But here, to extend the size, here 10 is already occupied, but it should be sequential. Then what memory manager will do is, and memory manager will create the array size of 3. Okay, array size of, and this 1 and 2 are copied here, like 1 and 2, and array of 2 is 3, 3 will be. See here, this memory is wasted. Actually, this memory is no need of us because it is already copied here. Then why is it? So this is very small array, but when we take big array, so much memory is wasted. So to rectify this problem, the linked list comes into the picture. Okay, so let's discuss that. Start. I have 3 nodes here, so I want to create some, I want to allocate this into this memory. So this first node came. This first node actually contains data part and next part. Data part is nothing but data will be there and next will get. So this can be arranged anywhere. So if some consecutive blocks are empty, then they can be inserted at any place. For example, see, this first block I'm inserting here. Okay, 2 is placed here. Then second block came. It is not mandatory that second block should be placed here only, because there may be some other data like in text is equal to 7. So what will happen? 7 can be placed here. No, 7 is placed here. Okay. Again, this second node came. Second node can be it. There is not mandatory. It is not mandatory to be placed after the next node only. So it can be placed anywhere. It can be placed anywhere in this node. Means, for example, 3 is stored here, but this first node should know that the second node is in some place. No, that is the reason this next part will contain the address of the second node. Means 120 will be stored here. Okay, the next node is in 120. Okay, and okay, now third node comes into picture. Third node can be anywhere. For example, third node is here. Okay, and data is 5. Okay, then what this node will store is, okay, this starting one, this address is 136, so 136 is stored. There is no other node, so there is nothing to point, so here there will be none. And again, there is something called head. So head will point to always the starting node. We should know what is the start node, so that the head will always pointing to the starting node. So that's it about, so why linked list comes into picture. But there are some disadvantages, because there should be some extra space for storing the addresses. Here, see, here 4 bytes, here 4 bytes, here 4 bytes, 4 into 3, 12 bytes are wasted for storing extra space for storing the addresses of the next node. So that's a part, but it has some advantages over the others. Okay, so now how to represent this linked list. So that was the another part here. So here in arrays we have some built-in representation. Int array is equal to new int of some size we are giving. So this is already inbuilt as there. But how we represent this linked lists? Linked lists also, if you know some Java collections, in Java collections it has, but I'm not saying about Java collections now. So how to create your own user-defined data type, because it contains some data and it contains some next. So this two will be stored. No? This two should be stored in some class. So we can create our own user-defined type here. Okay, using classes. So now what I will do is I will create a class of node, and in that I will place int data, and now this next will be pointing to the address of the node. So then this address of the node. Okay, so this address of the node is stored here. So node next. This will be pointing to that. So that's it. This is my own user defined data type for creating a node. Okay, now you may be somewhat confused. So what is this all the things? So let's code and let's understand. Okay, give me 1 second. Continue. So what I am doing is I'm creating some own class. So let me take like node.java. In that I'm creating my own class of in data and node next. Okay, up to here I created my own user defined data type. Now I want to create my main Java. So in main.java, okay, in this main one, what I'm doing is I'm creating the object of some other class, let's say linked list.java. Okay, in linked list.java, what I'm doing in this class is I'm creating some node head is equal to null. Initially, my head will be null because there is no nodes here initially. Initially, my head will be null. Then I'm creating some public void insert method. In this insert method, I'm passing data to store the data inside the node. So when I pass, so where it is implementing here, I'm creating some linked list object here, new linked list. Okay, I created object and I'm calling list dot insert of. I'm calling like I'm passing 2. Then what will happen here? Sorry, here. Okay, some data is passed. So that data should be inserted in this node class. Okay, what will happen here is I will create again object of this node. New node of, okay, new node. I'm creating, sorry. Okay. So after creating new node, what will be my node dot data? Node dot data will be data and node dot next will point to null. Okay, up to here clear. But there is some other thing here. What I want to do is, here there are two conditions. I will explain, don't worry. So in this main.java, what I am doing in this main.java, okay, so this list.insert method is called. Insert, okay, list.insert method is called. So in this insert method, I pass 2. I pass it 2. So what will happen in my data? There will be 2. In my data, there will be 2. And I'm creating a new object of this node class. Okay, new object is created of data part and link part. And data, in data what will be there? 2 will be there. And then next, null will be there. Okay, because there is no other node to point out. No? So initially it will be null. And what why I'm writing this if condition is, see, initially my head node is null. My head is equal to null. Okay. So initially my head is pointing to null. But one node is inserted no. So I'm saying that okay, this is the starting node, then it should point out. I mean head should be point out to this first node. Okay, then what I'm doing is here, if my head is equal to null, then my head will point out to my first node. Otherwise my head is not null. Then what I'm doing? Simply, if head is not null, for example, so I inserted the new node, no? I inserted a new node. Data is 2. Here it is null. And my head is equal to is also null. Then what I'm doing? Okay, null is erased. Null is erased and head is pointing to this this one. Okay, my head will be this one. Now again, I will call the other insert method. So list dot insert of, let's say, 5. Okay, then what will happen now? Okay, again, what will happen? This new node is created. Data is 5 now, so 5 will be inserted and next will be null. Then head is equal to null? No, because head is pointing to the first one. Okay, in else part it will come and it will check whether my head dot next is not equal to null. Here head dot next is equal to null only, no. Then it will come out of the loop. Then this null will point out to this one. Okay, see, I will write that. Okay. Then what will happen is I initially take like node temp is equal to head. I'm initially taking temp as head and I want to traverse this. I should not change my head. No, head will point out to here only. But to check whether the next is null or not, I'm taking some temporary node and I'm checking while this temp dot next is not equal to null. Then my temp is equal to temp dot next. At last, temp dot next is equal to node. What is happening here? Again, let me explain this with an example. This is all the things. Okay, here there will be none. Okay, this head is like this. Now new node is created. It will come to else what because head is not equal to none. Else what I'm creating a new temp. That temp is pointing to this head. Now I'm checking why temp dot next not equal to null. This temp dot next, what is temp dot next? Null only. Then what is happening now? Okay, this loop is stopped and coming out of the loop. Now temp dot next will be my node now. Temp dot next will be my node. Again, let's say I'm calling some other insert one. Let's take like this. List dot insert of 7. I'm inserting 7. So what will happen now? Again, we can check with this. Now what will happen? I'm creating some new node. Okay, so new node is created. In this data 7 is placed and this next one null is placed. So here is my head is equal to null. No, already some node is there. Then what I want to do, I'm taking some temporary array which is pointing to this head and this is node. Okay. And now temp dot next not equal to null. Okay, temp dot next is not equal to null because it is pointing to some other node. Then again, temp is equal to temp dot next. Okay, here spelling mistake. Temp is equal to temp dot next. Now again, my temp will go here. And again, I will check whether my temp dot next not equal to null. But temp dot next is equal to null. So it comes out of the while loop and temp dot next is pointing to node. Means instead of null, I will place here null. That's it. That's it, inserting a node into the linked list. Okay, now we can see how to get elements from each node. Okay, how to print the elements. So let me write some function here in main.java. I want like this. So list.show. I want to get all the elements from the linked list. So in this one, implementing public void show method. In the show method also, I'm taking initially temporary node which is pointing to temporary node which is pointing to head. It's also very similar to inserting a node. What I'm doing is while temp dot next is not equal to null, then simply I am printing like system dot out dot println temp dot data. I want data. So that's it. Now I want to take my temp to next node. No, so temp is equal to temp dot next. That's it. So okay, I think let me trace this also. Then you can understand, because I want to add some other line here. So why I'm adding, you can understand. Take some other color. Okay, initially my temp will be here. My temp will be here. And I will check whether my temp dot next is not equal to null or not. If it is not equal to null, then I will print 2. Then again, I am taking this temp to here. Then what will happen? Again, it will check whether my temp dot next is not equal to null or not. If it is not equal to null, it comes inside the loop and it will print 5. And again, temp is equal to temp dot next, means temp will be placed here. Again, it will check whether my temp dot next is not equal to null or not. But here, next is not, sorry, it is equal to null. Then it is coming out of the loop. But my last element is not printing now. So at last, what we should write? System.out.println, again temp.data. Then we will get all the elements. So what is the one that we want to write? At last, then we have to write system.out.println. Like temp.data. That's it. Let me save all and let us run. So let me take my terminal. Okay. Java space main dot Java. No errors, good. Java space 257. So that's it. That's it about creating a node using our own user defined data type. And in main function, we created the object of this linker list. So what we are doing in linker list? Simply we are doing insert method and show method. So for inserting the elements and for showing each element from the linked list. Okay, so that's it. That's it about this video. Thank you, friends. Thank you for watching this video. The coming up video is adding node at the starting position of the linked list. So we are adding the node at the ending position all the time. So now we can see how to add the node at the first and how to add the node at the last. Okay, and how to add the node at the middle. This all will come in this linked list only, but that coming up topic is how to add node at the first of the linked list. Okay, so wait for this video. So subscribe to my channel Quick Coder to get notified for the further videos. Thank you for watching.